once. Now,
thank you, Dr.
Again, yeah, no problem. So this is assignment 3, and we have 10 questions. Now, assignment 3 has a lot of sub-VIs. So most of the work are VIs, but you have to define them to be sub-VIs. Okay, this is number 1. Right. So question 1 here, exercise 1. Now it says create a sub-VI. Whenever you see sub-VI, this means you need to look for inputs and outputs. Okay, so this is sub-VI that returns the sum of non-prime numbers. Okay, so this between x and y both equal. So generating numbers between x and y, this was straightforward. We did it in the previous assignment. Now, how to check non-prime? For this, you will need a conditional indexing tunnel. Okay, so you'll use a for loop with a conditional terminal. A for loop with indexing tunnel. The indexing tunnel has to have the conditional terminal as well. Okay, if you don't know what that is, or you need me to make a fast revision, just let me know. I will show you the conditional thing. Okay, anyone doesn't understand exercise 1? Okay, so exercise 2, again, there is sub-VI. It should convert from Cartesian to polar. So this is this was an assignment number 1, except here it has to be a sub-VI. Okay, the inputs of the sub-VI are x and y, the x and y coordinates. Inside the sub-VI, it should calculate r and theta based on these equations, and the sub-VI should return two outputs, r and theta. So this is straightforward. Don't forget to use proper icon, basically for all the sub-VIs. There is a grade on this icon. Okay. Exercise 3. This is same as in which assignment? The last one or the one before, where you have this AFS system. Okay, so the equation is very simple. The sub-VI should accept theta here and s. Right. Inside the sub-VI, you calculate the equation and you return phi. And now bear in mind that phi is in degrees. This is automatically handled by the equation, so you don't have to do anything, do any conversion. Theta is in radians, so theta is in radians. So here just plug the numbers directly in the equation, no need to make any conversion. Again, remember that you need to use an icon, so don't forget this. So this is this. Question?
دكتور عندي سؤال، بس السؤال exercise 3.
Yes.
دكتور الحين الثيتا بتكون راديان، إنزين إذا أنا خليتها في الإكويشن هذا الفاي بيطلع ديجري بدون أن أسوي أي تحويل، أي كونفرجن.
يس، هو الكونفرجن والكونستانت والسكيلينج كله محطوط بال60 هاي.
أوكي صح.
فمعمول هذا يعني تحويل جاهز. It's ready. Conversion is ready. It will give you directly in degrees. Okay, so no conversion. Exercise 4. Now sub-VI, but now it should accept an array. It returns an array. Now the array has n random numbers. Okay, between 0 and 1. So this function, we really know how to use this function. You just create random numbers. Now you need n random numbers, where n is the input of the array of the sub-VI. So you pass number of samples you want to the sub-VI. The sub-VI will return an array containing these round numbers. So this is just a for loop. Simply, it's just a for loop. Okay. Okay, so if anything is unclear, please ask. Yeah, this will make things simpler to you. Exercise 5. Again, this is sub VI. Okay. It accepts a numeric array. So here you pass an array to the sub VI. It means you have to create array of controls, numeric controls. This way you define the input of the sub VI. And the sub VI should return the number of positive elements in the array you have passed. So imagine you are passing a sine wave and the samples of a sine wave. Now you should count how many positive numbers there are in these samples. Okay. This is the input is numeric array. You know what this means. You should make array of controls. Control array. It's hard to write in PDF, but okay. Numeric output. So this is just a scalar. We have one. Here it has the hint, so the hint is very clear. The only thing we did not study is this function. Okay, greater than 0. Okay, so here you extract the array using a for loop, element by element. Check each element. If it is greater than 0, then tell him counter equals counter plus 1. Okay, so this counter you'll be using a local variable for this one. Okay, sure. So if number is greater than 0, increase. If it's not, don't do anything. Okay, so this is very easy. This is not supposed to be here, so I'm going to skip this one. It belongs to the next page. Question number 6. Sub VI. It accepts two arrays and returns the dot product. So this is more than easy. Okay, we just use the multiplication VI. You have one array here. Automatically it will give you an array containing the multiplication of corresponding elements. Then you'll find the sum. So it's very easy. Question 7 has a long text, but it's very simple. Okay, you have a circle. This one here is a circle. Now the circle has been sampled. You have a lot of several points here on this circle. Okay, each point has an x coordinate and y coordinate. So in general, if you have a point like this, the point has an angle of theta, then the x value is cosine theta and the y coordinate is sine theta. Now we need to sample a full revolution of this circle. A full revolution. Okay, so here if I sample the circle and you have points, now here I substitute theta as I need theta to become from 0 to 2 pi with n points. So I have n points. I should place n points in the circle, and I need the argument of the sine and cosine to become from 0 to 2 pi. So this justifies the constant here, and here you have I, which is just an index. So I will go from 0 to n minus 1, and to generate such I you need a for loop. Okay. Alright, so here it simply says you need to create a sub VI that returns two arrays. Today actually we will solve a tutorial similar to this one. Okay. You need two arrays, x array and y array, with n number of points, where n is an input. Okay. So you pass n to the sub VI, it will generate n x coordinates and n y coordinates. Okay, and returns them as two outputs, x and y. Okay, so now 8 and 9, they are just exercise 7 but repeated. Exercise 8 says that you need one output instead of two. Here it says two outputs, two arrays. Here you have one output, which is a cluster of two elements. First element is the X array, second element is the Y array. You'll see this today because this is very useful for XY graphs. Okay, so for this you'll use a bundle function. Here you give the X array, here you give the Y array, and here you will have your output cluster. Okay, and you define this as output. So it's very straightforward. Now E9 is very simple. Instead of passing two arrays like this, X and Y, you need to bundle pairs. Here you just give him X point, Xi, just a scalar, not array. Here Xi, and here you'll be placing this in a for loop. Okay, and you'll get your array here. This is your output. Okay, this is exercise 9. So basically you have 7 exercises. 8 and 9 are very straightforward. Question 10 is easy. It's just written question. You have to have a written answer. We do use clusters. What advantage of clusters over arrays? Okay, and we have seen the answer for this during the lab. All right. This note here we will study today.
دكتور
So what we'll study? Yes.
عندي سؤال بس ممكن تصير exercise 7.
اوكي هاي
الحين دكتور هذا الاكسرسايز الانبوت بيكون الثيتا الانجل.
يس
زين، والاوتبوت يعني بيحسب لي انا how many values from the zero to the angle ولا بيحسب لي
لا these are theoretical equations, these two.
Okay.
Let me just do it. Okay. So these are just theoretical. It's not writing. Yeah, it's theoretical, tamam. But now I need samples on the circle. So I should have theta 1, theta 2, theta 3, and for each one you have x1, x2, y1, y2, etc. And I should sample theta. Okay. Now, how many samples do I need? This means how many samples you will put on the circle here.
Okay.
Following? Yani the more the better.
Okay.
So here you pass to the sub
okay.
vi. Yeah, you pass to the sub vi. It's not right. Yeah, you have a sub vi like this. You pass.
هو تقريبا يقسم النقاط اللي من الزيرو للانجل على حسب هذا الان.
ايوه exactly. كيف تطلع الفاليوز؟ Yeah, how to get the values using these equations. The 2 pi over n خلاص يحسبها because the sub has the value of n. I think. Okay. So n you have it because you pass it to the sub vi. 2 pi is constant, and I comes using a for loop. خلاص for loop it will iterate n times. Each iteration it will give you a y point and an x point. Like that.
واضح يا دكتور.
Then you'll have two arrays directly wire them to the yeah. So I think I have solved.
دكتور عندي سؤال بس برا هذا شوي برا الأسامي. دكتور أنا نزلت الفيو لاب، ويوم نزلته حاولت اني اسوي لوجن لاب فيو سوري. يوم نزلت سويت لوجن ما طلع يستوي لي، فسويت هذا يسمونه 7 ايام فري، وحليت الاسايمنت واسايمنت، والحين انا متوهق ما اعرف كيف ارد. يعني ارد مره ثانيه اسوي احط الايميل اسوي هذا ما طلع يستوي لي يعني.
No. From start menu here, go to NI license manager. This one.
اوكي.
زين. are you following?
NI
الحين NI license manager. You will have.
اوكي دكتور ضغطت عليه.
The option. Yeah. So you'll have your software here.
Yes.
Press anyone and tell him activate software. Okay. Now.
Software.
Tell him ترسيل.
سوري دكتور ما سمعتك شو قلت؟
Enter serial number. Then you enter the serial number here for all of them, same serial number. بعدين tell them activate. Press activate. تمام.
اوكي. السيري نمبر وين طلع دكتور؟ اوريدي في هذا لان ما انتبهت لهذا الستيب.
السيريال number I gave to you, I gave to everybody. This is M72X. Comes 765. So this is it. I sent it in the email, right?
والله ما انتبهت للايميل دكتور سوري.
وعقب put it here in the chat. خليني احط لكم اياه بالشات. طب شو طلعنا هون؟ لا ما هي. بعدين you put it for each one of those, then you press activate.
For each one دكتور ها؟
تمام. Yeah, for all of them. بعدين خلاص.
بعدين اسوي له activate.
See here I have some of them unlicensed because just took care about them. You just need LabVIEW as
LabVIEW
2019 as.
خلاص مشكور دكتور.
Yes. Anyway, so إذا عندك صعوبة بعد اللاب إن شاء الله نحاول إن نحل المشكلة. Okay. شو استوعبنا؟ Alright. Okay, so this is assignment 3. I hope I have عوضنا عن تأخير الناتج إنه تأخرت فيه أنا. Okay, so this is. Okay, so today's lab number 4. This is the last lab on LabVIEW. Okay, we will conclude our programming techniques and aspects about LabVIEW. Okay. With following 2 things. So today's lab is very simple. We just will learn about plotting data. Okay. So basically, I have one section only, which is plotting. And if I have time, I will give you extra thing about projects and data types. Okay, so mainly we focus on plotting. All right, so last labs you have seen execution control structures, while, for, case, float sequence. We have seen local variables. We have seen arrays and clusters. What else did we study? Conditional execution, case structures. So these were like the main topics. Okay, now plotting is very, very important. because, as engineers and scientists, we need to communicate visually, and plotting will give you a very efficient tool to share your data and present. And monitoring applications, plotting is very important, where you plot your measurements in a live fashion, like online plotting. So the importance of plotting is very obvious, right? So this is very important. Right? LabVIEW, we have 3 ways to plot our data. Basically, we have waveform charts, we have waveform graphs, and we have XY graph. Okay. So always, this is very important thing. You need to distinguish between a chart and a graph. So these are charts and graphs. Okay. I think I'd rather write on the Word better than the PDF. All right, so this is better. So we have to time. Okay, sure. So chart means with respect to time. Okay. However, graphs can be with respect to time, with respect to index, with respect to several things. All right. شو صار بالصوت؟ Okay, Shab, can you hear me?
Yes, Mark.
Hello, can you hear me?
نسمعك دكتور بس شوي يقطع.
Yeah.
الحين اوكي دكتور.
So so last thing I would say is that with respect to time, while graphs can be with respect to index or with respect to arbitrary values. Okay. All right. So let's begin with the waveform charts. These are the simplest and most useful let's say, or indicators. Okay, so here so here we will plot two random numbers on a single chart and keep the value history. So what does it mean to keep a value history? This is very simple. I need here to where is my
Doctor, we cannot see the PDF.
You cannot see the
Okay, now
PDF?
okay.
My screen, can you see my screen?
Now I can, yes.
Yes, Doctor, now we can.
Yes. I'm switching to a faster network to avoid this interruption. Alright, so waveform chart. Now here it says I need to plot two random numbers. Okay, on a single chart. The value. So, what does it mean to keep a value history? It means if I plot a point like this and I have a new point, each time I have a new point, I want to return the history of my values, whatever I have before. Okay, this is one important aspect of charts, is that you update your plot point by point as you execute your code. Okay, while graphs, in the graphs you have to provide all of the data as one chunk or one piece like this. Okay, so this is what we mean by keeping a value history. Okay, we want to keep our history of plotting. So so this is this. Now let's open LabVIEW. Right, and I'll create a new BI. Okay. Do you all can see my screen? Is my
Yes,
screen
we can see it,
clear?
Mr. Ali.
Yes, we can see, Doctor.
Do you hear any noise? I think the voice can be noisy sometimes.
No, it's okay, Mr. Ali. We can hear you fine.
Okay. Sorry about this interruption. Okay, guys, can you hear?
Yes, Doctor.
Hello, can you hear me?
We can hear you. We can.
Yeah. Okay. All right. Sorry, I've switched to faster network. Still telling me poor quality. Never mind. Okay, sure. So let's create a chart on the front panel. Okay, so here in the front panel, I will go to graph. Basically, we'll use chart, then a graph, waveform graph, then XY graph. So all of what we'll use today is here. Right? I'll begin with a chart like this. Okay, so automatically here on the block diagram, you see an icon. What's this icon, Joe? It looks like a numeric indicator, right? They look the same. Okay. So basically, this is the first thing about waveform charts, is that they can accept scalar values. So any scalar numeric value can be plotted directly on the chart itself. Okay. Now to create two random numbers, I need to get them from numeric here, and another one. Okay, so I have two random numbers because I need two plots. Okay. Okay, so let's plot one of them, and then we will generalize to plot more than one. Okay, so at least I'll plot one of them. So if we were this directly to the chart, automatically it is accepted. Okay, so here I see just one scalar value, not an array, and the chart will plot that value directly. Okay, so this is very, very simple. Now if I run my VI, now I have executed one time, I've created one point from here, and this one point has been displayed directly on the chart. If you run another time, you'll see that you have a line and you have 2 points in the chart. Right? So here, if I right click my chart, in the X scale, I will enable auto scale. So basically, the X scale will automatically be scaled to show all the points. So here you can see now that each time I run my VI, okay, I will see a new point in the chart, and all of the previous points are still there. Okay, it doesn't just one plot one value. It will add this value or this point to the history of points you had before. Okay, so each time you run, you will have a value like this. Okay, so this is one property of charts, is that they have memory. Right. So these are charts, they have memory. Why is this appearing? Okay, so what's the length of this memory? This is question number one. Now if you right click this chart, in data operation, no, in advanced, you will have some no, sorry, it's here, chart history length, and here you have 1024. So actually this chart will retain 1024 points. Now any new point that arrives will replace the first point that has been plotted. So basically the maximum number of points that can be displayed at once on this chart is determined by here, and you can change this number. If you want to try 5000, you can put it like this. And this is just for charts. This property of charts is to define the history buffer or the history length of this chart. So here each time I run, I have one new point. You can see here that you have a line, okay, simply because this the chart will connect the points together through this line. If you want to show the points themselves, here in this legend, you can click this plot, and common plots, you can choose the style of your plot. Now I can see my points and the lines connecting them. Okay, Shabab. Is that clear, or Shabab, can you hear?
Yes, doctor.
to hear from you because, again, I don't know if the network goes down or you are thinking of me. So this is this is charts. So they are very simple. Okay. Now, what we'll do is we will continuously execute the loop. So we'll make the loop run continuously using a while loop. So basically, I'll enclose all of this guy here with a stop button. Done. So this way, it continuously generates random numbers and displays them on this chart. Okay, so if you run this one here, this is very fast. And the length, I think the length is too much, so I will restore this to 1024. Alright, so this is clear that this is like it looks like a noise or like it's just a random number. Okay, and I can see here the maximum is around 1, the minimum is around 0. Most of my values may be around half of that, so maybe this is normally distributed. I'm not sure. So this is it gives you like a visual meaning for your data. Right? Okay, so I want to slow down my loop because this is too fast, and I would like to give this x-axis a meaning. Okay, now by default, what's the default meaning of this x-axis? This is just the index of your point. Okay, to explain this better, I'll remove the while loop like this, but first I need to clear my chart. Okay, so if I right click the chart in data operations, I can clear the chart. Now this is fresh. Okay, so by default here I see 0 and there are numbers until you have 1023. So this is just the index of the point. So the first point you plot, it will have let me show that point. Alright, so this here, it has an index of 0, so here this should be 0. The second point, it has an index of 1. Then you have 2, 3, 4, 5. The x value will increase by 1. Okay, so this doesn't have a time meaning. So in order to have a time meaning for this, I need to find the time interval between each two samples. Now if you run like this, you don't know the time between each two clicks, so this doesn't make a sense. But if I have a while loop, then I can time my while loop like this. And here I can time my loop. Okay, using the wait function, and the manual says use a second. So I know now between each 2 points there is 100 milliseconds of time. Okay, so if you run, still this is increasing index, but now you have the time. You know what time between 2 points, right? So now to give this a time meaning, you have to multiply these values by the time interval that you are doing here, which is 100 milliseconds. All right. Now here in this video, there's a YouTube video here. It explains how to manipulate your the properties of your graph. Okay. Now I'll explain them directly. Now by now you see that you can do some visual styling here. Here I can show just the points. Here I can show the points and align connecting all of them. You can change the color of your plot from here. You can choose that this is red, yellow, any color you like. If you expand this one, now you have plot 0, plot 1. Now you can control more than one plot. If you have more than one plot. Okay. What else do you have? Line width. You can control the line joining these dots. You can choose the style from here. So you have a lot of parameters that you can manipulate. Now if I right click my graph and I go to properties, I have scaling factors. Under scales here, I have scaling factors. Okay. Now this one is very important. What I need to do to make these values have a time meaning is to multiply all of them by this time interval. So this is 100 millisecond. So this here should be 0.1 as a multiplier. In this case, it will multiply everything by 0.1. Now in the style here, doesn't show the intermediate numbers. I can enable this from the scale style, like this. Okay. Now still the display, I want to show fractional numbers here. So you have to go to display format, and you are in the time or the x-axis. I want this to be a floating number and show me 3 digits like this. So you see 3 decimal digits. You can choose of precision or significant digits, the way you want. Okay, so, so if I clear my chart now, clear chart and run, you see now that here between the first and the second points you have the time of 0.1, but then you have 0.2, 0.3, 0.4. So now the time interval between 2 points is the one you have defined here. Okay, so this is done by doing a scale on the time axis. Okay, same thing I can do here on the amplitude. If I choose here the amplitude axis, now you can change the style. You can change the scale here. You can change the color. If you want to make some grids, you can make some grids. If you make white like this, you can show them. Okay, so same for Y. You can make grids here. You can show grids. So this is like squarely gridded, which is not visually not user friendly, but these are some of the things you can do. Right. So in scales you have X scale and Y scale. You can choose them. The one, of course, here you can choose linear. You can choose logarithmic. You can invert your scale, etc. Both for X and Y. In display format, you can choose the numeric display for this graduation, say both for X and for Y axis. The rest are, I rarely use these. It's like I think the properties of the plot, the size, if you want to make some documentation, etc. Okay, sure. So I'll keep it as it is, like this, and run. Okay, everyone, you understand the charts? Can you hear?
Yes, doctor.
All right. Any question about charts? Now I need to plot two values of two variables at the same time. This is steps, I think, from 6 to 8. Okay, so I'll summarize them like this. Now here I have one plot. What if I want to make another plot? Say I have another random number, or maybe I don't know, I want to multiply this random number by, I'll give you something tricky, like this. Okay, so I want to multiply this random number by something I control from here, and again plot it on the same graph. Okay, so in this case you have two plots. You have this random number and another one, a multiple of it. Now the rule is, if you want to multiply, if you want to plot several plots on a waveform chart, you need to bundle them like this. Okay. So to bundle, you know this previously, you need to bundle using a bundle function. Okay, so the first plot is the first scalar you give here. The second plot is here. If you have as much plots as you need, you can expand this depending on how many plots you want. Generalize. Okay. All right. So here I have two only, so I'll keep this like this, and then wire it. Automatically, the chart has adapted to this in nature. Now, if I run, where's my other number? It's there, but I have a 0 multiplier here. So if I raise the multiplier, okay, so now I can see that I have two numbers. I can change how they look from here. Now I have two plots, so I can expand this. Plot one, maybe let's have it yellow thing like this, orange. You can put points or leave it as it is. Alright, so now I have two plots. And this goes on. You can have as much plots as you need. Okay, maybe I want to plot I at the same time. So you see I has grown to a very big number, and this is, you see here the scales are auto-scaling. You can disable this from these two properties, the auto-scale X or auto-scale Y. Okay. While you are running, you can always right-click and clear your chart. Clear it until you have some satisfactory condition. Then you want to retain your graph. Okay, sure. So is that difficult, easy, or in between? All right. So this is about charts. Okay. So this is very easy. So when do you use charts? This is an important question. Now you can see here that while I am executing my code, I'm plotting at the same time. Okay. So there's one important property of charts, is that you are plotting while you are acquiring or while you are generating numbers, maybe while you are sending out values out of the PC or into the PC. So this is in the loop of acquisition or in the loop of control or monitoring. You are plotting at the same time. Okay, so these are very simple and useful. Now next thing is the waveform graph. Now we had seen charts, graphs, they are slightly different. Okay, now graphs do not, they don't accept scalar values, unlike charts. Okay, you have to create a group or a chunk of data before you can plot. You cannot plot in a point-by-point fashion. You have to generate a number of points and then plot all of them at once. Okay. And in general, they don't retain history from previous executions. So these are the three differences from the charts. Okay, so when do we use them? Let's see this example. This says here, plot a sine wave with a frequency of 50 Hertz. Use the following equation. And this one is theoretical equation. It's the continuous equation. Next lab we will see the difference between continuous, discrete, all of that. Okay. So here my time is continuous. This is my frequency, 50 Hertz. Sure. Now I need to plot this one, or an approximation for this one. Approximation in the sense that you have a sine wave like this. This is the continuous sine wave. Now it's hard or impossible to plot continuous things in computer. Instead, what you will do, you'll sample this. In the same way you have sampled the circle in your assignment. It's very similar. Okay, so you just need to create these values here. These values like this. Right. Okay, so let's create a new VI, and what you'll do basically, I have all of these input arguments of the sine defined outside. I have 2 pi times 50, so this is 2 pi times 50. Okay, but now instead of having a continuous t, what I will have is delta t. So only at discrete steps or discrete points of time, I will calculate or find the result, which is the sine for all of that. Okay. So here I have 2 pi times 50. Okay, so this is here 2 pi times 50. Now inside the loop, I decided to generate 50 samples. So inside the loop, I multiply all of this by I. Okay, so basically you are calculating the sine at integer multiples of this delta t here. Right. At the end, I'll collect all of my samples in an array using the indexing property of a for loop. Okay, sure. This is very, very useful use for these indexing tunnels. All right, so let's do that. Now I need to generate an array of sine. Okay, so I need a for loop. How many samples? We can decide this by trial and error. Let me put 50 here. I have 2 pi times frequency times the time. So 2 pi this is 50. You can put it as 50 or you can put it as variable. For now, let's put it 50. Maybe I'll put double click here. And this is the frequency. Okay, sure. So here I placed a comment on my block diagram. So 2 pi times 50 times. What is delta t? So I choose. This is 1 millisecond as delta t. And inside the for loop, I'll multiply by this integer. To understand this, why are we doing this? Please stop me at any time. So now I need a sign. I need to take sign all of that. And then the output, I'll send it directly to the start here. All right. So automatically I can see that an indexing tunnel has been created here in the for loop. So sending okay, sure. So I'll give you some time to complete this one and probably step number 2. Okay, so excuse me, and I'll be back in less than a minute. Okay. Okay, everybody. So I'm so sorry for this interruption. So we'll continue from step number 1. Okay. So here we have made the for loop that will generate an array for me. Okay, which is the output of this tunnel here. Okay. Now, if I place in the front panel, if I place a graph, okay, automatically I see here that I have a numeric indicator. Now it looks like an array of numeric indicators. Okay, it tells you that it can accept an array. If you are this directed to the graph, now the graph will automatically plot the array components as I can see here. Okay, so this is my result. Alright, so this is the first way to use your waveform graph. The problem with this approach is that I don't have a time information contained in this plot. Okay, these numbers here are just the index of the elements of the array. Right? So here you have 50 elements in the array. Yeah, 50 elements here, so you get up to index 49. Right? Okay. So in order to use the time information in the plot, we don't plot the array directly like this. Instead, we build what you call the waveform graph. Right? So here from the waveform subpalette, I will go and select build waveform function. Okay. So what is our waveform? Similar to the array, except that it has some time information. Right? Automatically see here that you can expand this. Right? And the first attribute it has is the array y. You can select t0, you can select dt. Okay, and that's it. These are the 3 components of the waveform. Right? So the t0 will tell the graph the initial time where you are plotting or you begin your plot. dt is the time interval between samples, and y are the samples themselves. Okay. Now t0 is optional, so I can neglect this one here and then just use the y array and the dt value. Okay. With the dt I have used, which is this one, this is my dt or the time increment. Okay, I'm going to use this one to define my waveform. Okay, so my dt is the time interval between 2 samples. Now, if I were this directly here to the waveform graph, it changes the color. This is the color of waveform data type. And if I run like this, now I have the same plot, but here in the x-axis I see a realistic time. Okay, so now I can indeed describe this as time. Okay, so this is waveform chart. Now you cannot wire a scalar to the waveform chart, to the waveform graph. So if you wire a scalar directly to the waveform graph, it will not accept this. You either wire an array or a waveform using the build waveform function like this. Okay. But this is extremely important when you are doing realistic data measurement. Okay. If you see here, and these measurements IO, automatically they will give me an output waveform like this. Okay, so this VI actually connects to data acquisition hardware, and it will automatically give me a waveform similar to the one I have generated like this. Okay, so when we are dealing with hardware and input and output, waveforms are the best means to handle the acquired data. Okay. In addition to this, when I'm doing some measurements on my signals, if you are doing here in signal processing, if you're doing some waveform measurement, for example, I want to measure the frequency of my waveform, you can tell them extract tone from this. Now this VI automatically accepts a waveform. Okay. From internally, based on the algorithm implemented inside it, it will extract the Y elements and the time elements, and then it will consequently, or at the end, give me the measurements, which is here the frequency. Okay. So here I have created a frequency of 50. When I measure it, and the detected frequency is exactly 50 Hz. Okay. So waveforms are really important because most of the signal measurement, conditioning, and acquisition uses them to handle data. So any question till this point? Any question or any note? Okay, so I'm not sure if you can hear me clear or if you don't have a question. Yes? Are you all with us?
Yes, Mr. Ali, we hear you clearly.
Okay, very good. It's good to know that you're not asleep. All right, so this is about graphs. Okay. Now we will see how we can plot several graphs. Okay, if we have more than one graph. Now here, a sine. What if I have another one, say a cosine or tan or whatever? Okay, that's very simple. Let me place a cosine. So what I need to do is just make the cosine of this, and then I'll build an array like this. Same way, I'm going to build a waveform. Okay, and I will use the same DT. Okay, so now I have two waveforms. One is sine waveform, and one is cosine. Now to plot both of them, now in charts we used to bundle. Here I need to make an array of these two waveforms. So bundle will not work with, if I bundle two plots like this, the waveform graph doesn't accept them. Actually, you have to do an array of waveforms. So I will use build array function. So this is my first plot, which is plot 0 here. Okay, then I have another plot, which will be plot 1 in the red here. So the white plot, the first one here is the cosine. So this is the white. The second one here, this is plot 1. This is the red plot. Okay, so now you can see here you have 2 brackets to tell you that this is an array of waveforms. Alright, so evidently here I can see that you can see the cosine and you can see the sine. Okay, and so on. You just put a new array, build another waveform, add it to the waveform array like this, and then you'll have a third plot. Okay. So you have done this. We have done this. We have done this. And okay, let's see this node. Now we can observe here that each time I run my VI, I will have a new plot. Okay. So what the waveform graph is doing, it will clear whatever was in it and then plot a fresh plot. Okay. So it will not return history. It will not connect this plot to the previous one. Each time we have a fresh new plot on the same graph. Okay. Here you don't have a history length, unlike the chart, and you cannot retain the plots between execution. And we can change. Now I can see the new plots, but the old ones were completely lost. Alright, now this video here will show you some of the properties that we can do with the graphs in order to manipulate the appearance and to do some measurements on the graph directly. So I'll leave this video to you. It's very straightforward. You just right click and show. We have 2 important things: the scale legend. So graph palette here is the most important one. You can manipulate your graph like this. You can zoom in the X direction. You can zoom in the Y direction. Like this. Okay. To select points in your graph, you can select this directly. You have to show the cursor legend. Okay. Now I can add cursors. I can right click here, create cursor. I'll tell them single plot. Now I'll select this cursor moving tool. Now I can select my cursor like this. Okay, automatically it will snap to the points you have in your plot. These points are not shown, but I can show them like this. Alright, so here this is snapping to these points, and each point has an X value and a Y value. Okay. It's very important. We are doing some experimental measurement, and you want to measure something directly in the graph. That's not the most accurate way, but say you want to find the peak here on this plot. So now I know the time to this peak is 5 milliseconds, and the peak value is 1. So if you're going to find the minimum in the graph, you can place this to the minimum and then find the time and the value. Okay, so this is the cursor. Okay, the rest is straightforward. All of this are in the video. there's nothing significant to be explained, nothing tricky about them. But I advise you to go ahead and watch this video. It's just 2 minutes or 1 minute. Okay. Any question about the graphs before we move to XY? All right. So this was the waveform chart. Now I'll move to the XY graph, okay, which is the next topic. So XY graphs, as the name implies, these plot X data versus or Y data versus X data. Right? So these are the most general displays. Okay. The important thing about them is that they require both X data and Y data. Okay. In here you have to supply an array of X points, and here you have to supply an array of Y points. You have to supply 2 arrays. Okay. Now there are 2 options to deal with them. Either you supply a cluster of, like this, you need a cluster of 2 arrays. You have array X and you have array Y, and you'll have your cluster. Or you will have an array of cluster of XY pairs. Okay, this is tricky. Let's see both approaches to XY graphs. Now here it says plot a circle of radius 1. This is my task. So it's very, very simple. Same as in assignment number 3, there is a circle and we need to plot the circle itself actually by plotting points on the circle. Okay. Now what I will do, I'll borrow this code from the previous BI. Right? So code on UBI, minimize this one, again like this. Okay, now I don't need this build waveform. Okay, so here clearly I have 2 arrays. Okay, I've seen this before. Okay, so to plot a circle, what do I need? Okay, to plot a circle like this, you have a circle. Okay, so what you need is sample points in this circle. Okay, so each point has an X coordinate and it has a Y coordinate like this. Okay, so these points, this is the X array, and these points are the Y array. So let me put undo, let's undo. This red. This is X array and this is my Y array. 2 arrays. Okay. Right. So X simply is what? Is cosine. I will use delta theta here maybe times I, and Y is sine delta theta. So delta theta is the increment between 2 points. How much increment of theta you need between 2 points. Okay. So all what you need to do is to generate these 2 arrays. This is what you need. The X array and the Y array. Alright, so programmatically this is very, very simple. right? So here they are already created. Okay, they are with respect to time. Okay, but I'll take them. Nevertheless, I'll take these two arrays. All right, the rest is easy. The two arrays are already accomplished. Okay. Now, choice number 1 in creating the XY graph is to make bundle of what? What do I have? This is my X array. Why is this X? It's because I am doing cosine here. And this is my Y array. It's because this is a sine. Okay. And we're already familiar with this bundle function. So this is straightforward. I'm going to place an XY graph. This is my XY graph. And I'll make a cluster of two arrays. This is the keyword, cluster of two arrays. Right. Now if I execute here, directly I see my circle like this. Okay. Now where are the points in my circle? You can show them like this. Okay, let's just join the points. And they are here. But if I choose less number of points like this, so the less number of points, the less complete your circle will be. So 20, 21, so it's like this. Okay, so this is choice number 1. I've made a cluster of two arrays. Choice number 2 is to make, actually I'll keep everything. Let me just copy, you know what, I'll expand this. Okay. Instead of doing a cluster of two arrays, I will do array of cluster of X and Y points. So what does this mean? It means each X and Y coordinates, like point by point. Now instead of doing this outside, I'll do it inside the loop, because I have to bundle each X and Y points and then make an array of those. And that's it. So basically, this is an array of X, Y pairs. Okay, so this is, let's call it XI. This is XI, and this is Y. Okay, now if you plot, you have exactly the same thing. Okay, sure. So this is the alternative way to deal with XY graph. Okay, one question to you. Which one is easier? To make a cluster of two arrays or array of clusters? Or which one is more similar to MATLAB? This method here or this method here? Okay, this one or this one?
A cluster of two arrays, I guess.
Yes. This one is more like MATLAB, so? Because MATLAB you do plot X, Y, two arrays. But why do I have this choice, or what's the point of this choice? This one here. Now you see, in this one, you have to execute the for loop. Sorry, you have to execute the for loop in order to get the X array and the Y array to make them complete. While this one here, no, you can plot just one point. Okay, so if you plot this one, if you send this inside, you can do something tricky. You can make an array of one element and plot it directly here on the. You'll see that you have one point that is moving. So if I slow down my loop, let me just disable the scales. I'm just adjusting the scales of my plot. I will disable automatic scaling. Okay. So now if you focus here, you have the point here. You'll see that it is moving. Okay, so it's like moving along the circle. Right? This is one advantage of having a single point plotting. While this, you have to have all the X, Y data complete, and you plot them all of them at once. Okay, Shab, so any question to this point? Is this clear to you how to use both methods?
Clear, Doctor.
Nice.
Doctor,
Okay. Yes. Yes, who has a question? Please ask. Don't ask, I have feeling distance, which is depressing. So guys, please ask.
شكله ما عنده سؤال الحين دكتور. خلاص جو كمل.
Nice. Okay. So now step 7. I'll show you one more trick. Now this is the loop here is okay. I'll stick to the first method, okay, which I have the graph for, like this. Now, what if I want multiple XY plots? You have to make an array of these things here. Triani means I need to build array. This is my first plot. بعدين I'll make similar one to this one, but with different XY values. So here, let's say I want to plot. I have a circle, but I want to plot the X projection and the Y projection. Okay, so here, what do I want? I will make an array of X. Yeah, you can choose. Okay, so make array of the argument here of the sign, and another array of the cosine. Yeah, let's see how this. And this is my second element of the array, and this is here. So I have array of plots. This is a plot. This is a plot. Okay. So here directly you can see that you have the X projection. This is cosine. Yeah, the X projection of this point. Why does it show like an ellipse like this? It's just a scaling of this plot. Okay, so we put minus 10 to 10. I'll show here. Yeah, you have to make the same scale here. 10. minus 2. Okay, so here the red one, I think this is too much. خلينا نحط minus 2. لا, minus 7. Minus 7 to 7. Okay, so you can see that the red line is the X projection of my plot. Now if I want to plot the Y projection, هذا الX projection ولا Y projection? Let me zoom. Okay, I will show the graph palette here the same way, and I will zoom this way. Alright, so this is a matter of choice. Actually, I should plot here because this is the Y projection along the X-axis, so I have to plot it like this. Okay, maybe this makes more sense. Right, this point has at the beginning is 0, yeah. So this is the Y projection, and I'm plotting this against 0. So I need a third plot مثلا, so I have to plot it blacks like this. This is here. Okay, it's just an exercise, so I have to show you that you can have several XY plots on single graph by doing array of clusters like this. And the clusters of what? Clusters of array. Right, so automatically here I can see that I have my yeah, this is the X projection. I plot it along the Y-axis. Okay, guys. Okay. Any questions you have till this point? Okay, let's summarize. We have seen, let me pick up this one. We have seen the charts. Okay, this is a chart. We have seen the graph, uniform graph, and the XY graph. Now the chart can accept scalar. Maybe you should put here some table. I have a question about each one. I don't know, the quiz and the assignment. Basically everywhere. So we need to understand charts, graphs. So chart, you have chart, let's put it in.
Sir, the quiz will be on the last week, right?
The quiz will be. I don't have problem making it next week or the week after or the last week.
Last week دكتور زين.
Next week is better, Mr. Ali. عشان we know the information is still fresh in our head, in our minds. ولا؟
Okay, I don't have problem.
This is what I think.
لا دكتور مرة شوي دكتور لا تحمس الله يخليك.
Next week? مين قال next week؟
أنا كريم.
مين بده next week؟
I'll raise my hand.
Now? Who said now? Who wants a quiz now?
دكتور no one said no.
Okay, سمعت بالغلط أنا. Okay, but usually you need a couple of weeks. بس إحنا شو الفكرة؟ Next week we will have data acquisition, so we'll practice more on LabVIEW. The week after you will have what do you have? I think another lab on data acquisition. So you'll keep practicing LabVIEW, but you will not have new topics. All of them will be arrays, clusters, loops, timing, all of these things. So you'll practice more. So probably I'll try to do it after the mid of the lecture part. If all students want, we can do it last week. I don't have problem.
يعني بعد شهر دكتور؟
يا last week متى بكون؟ احنا بننهي الخطة
شهرين بعد شهرين.
بعد شهرين دكتور، شهر 12.
بعد شهرين. أنا بنسى مش أنتوا. so خلينا نوقف التسجيل مشان الفضايح. دقيقة شوي. stop.